Good afternoon. My name is Hynek Syrovátka, and I will share with you a few slides concerning one of the puzzle that makes the whole thing working. One of the piece of the puzzle that will help us to make the things working together. I will start with the colorful slide made by Shimon that shows something I think I boldly named standard IQRF ecosystem. It's not a standard yet, but we are touching these pieces that makes the whole ecosystem and trying where it makes sense to make them standardized. So as you know, usually the most important part of the whole stuff is the product. The device that does what we need. It exposes peripherals that these other layers can use and use the device actually. By using DPA, by standard, you have something what we in the past called standard peripherals. We don't call it anymore standard peripherals. We call it embedded peripherals because those are the peripherals that you will get for free just by uploading DPA. The standard peripherals are the ones that we standardize these days, that we standardize with help of you, and I will get in a little bit more details later on. Above of that, of course, there could be a special things that are not standardized. You know, something really custom, like the fontaine and whatever you can think up. Yeah, and this is not what we will standardize. Of course not. We have the gateways, as you know. The team led by Rostya is doing good work to standardize it too. We would like to allow any hardware capable running Linux to have our IQRF daemon running on it and to actually form the gateway that would be used across the whole chain. There's MQTT broker, as you know, and of course there could be your app that runs, that drives the whole solution, yeah? And whatever else, as this is the machine running Linux, anything else could be running there. And those two entities cooperate using a DPA, yeah? And another layer is the cloud. Of course, it could store the data, make a computing, analyze it, visualize it. And using AQTT JSON, it's connected with the gateway. So this is the whole chain. And what we standardize. I am mainly focused on the device part of the standardization. So what I do with help of you and other guys is standardization of this DPA link between devices and the gateway. So that's the way how we come up with the standard peripherals. Rostya's team is working on the gateway part. So part of it is the standardization of the JSON format, of the JSON protocol that is used not only in this communication layer, but also, as you will see later on, in different places. We also standardized hardware profile ID. Hardware profile ID, as you know, is a unique number that uniquely identifies a product type. So every products that already run our standards have the unique ID. Simon had a working demo and other guys, so all these, this lamp has the hardware profile ID already allocated, yeah? Netio plug has the ID. Protronic has already an ID, and so on and so on. And more products are coming. Last but not least, I have to mention a very important thing that we already, as the idea, introduced in January, and it's a IQRF Alliance repository. It's the actual server running on the network that will, based on the same identification to the product type, provide services and information concerning the standardized devices. So there is going to be a database with all the means that will allow applications on the gateway or on the cloud to find out what the device is, you know, who is the producer, what standards is is compatible with. What's the size? What's the length? What is the last custom DPA handler to upload to? And so on and so on. So again, there is going to be a standardized API to call these services. So these API can be beneficial for both the gateways and the clouds. So both the gateways and the clouds will find out everything what they need to run your application logic and to use the devices without a need to code and decode these, for most of you, probably cryptic bits and bytes and DPA commands. You know, we want to let you, as typically integrators and also the product vendors, the life easier in terms that you will just call methods that will work with the devices. You know, just like something, give me the temperature, but not by coding the bytes and decoding back. So clearly, what's the motivation of the whole stuff of the standardization? First of all, device compatibility. So what we need, and it was already mentioned by many speakers in previous appearances, we want to make sure that all the devices that can measure a temperature, like the Protronics or these IoT kit boxes, they speak the same language. So they are compatible. This is really important. It's also a way how to make the things interoperable. So we try to design the standards in this way. Integration simplicity, I already talked about it. If I remember in the past, few years back, when there was even no DPA, all the project we prepared with the customer was really, piece by piece, absolutely different. So this is not the way. C-code it from the main message loop to the very end. Today, you typically just have to focus on your events, on your logic, and this is it. And we want to make it even easier. And it brings the fast development, of course. Many probably other pros will bring it, and at the very end, we want to have the IQRF, meaning your products and a success. So what are the basic rules we try to follow when designing the standards? Simplicity. As you know, even the IQ mesh and IQRF is by the design simple to use, lightweight, low power, and so on. And also, we would like to have our standards simple. You can see it. On the other way, it must be scalable. It must not be limited. If I say it's simple, it doesn't mean that the sensor is limited to one temperature sensor and this is it. I want to have it scalable. I want to be able to have dozens of sensors in one device of different types. So simplicity doesn't mean to be limited. Also, it has to be exception-free in terms of that we would like to put in our standards the standard things. If there is something really special, really custom on your device, which is not very common, this is not the place to be in the standard. Let's keep it pure, simple, to be easy to use. But on the other side, it must be a diversity aware in terms of that must be able to maintain many different, for instance, sensors. It must be able to measure temperature and humidity and radiation and this and that. We also try to use a very same way of working with the standards, kind of common patterns. You will see it a little bit later on. So today we have, let's say, on the device part, we have 3 basic draft standards. And all of them share the main ideas, the main things, like how we address the devices, how many devices can exist inside, and so on and so on. Very common patterns. So what's the progress of standardization? The task came this January actually, on the IQRF meeting. And so first step to do was to establish a technical committee. So technical committee exists. Many of you are part of it. We regularly meet once a month over the Skype and discuss the progress, what's going on. And of course, this is not an only communication. We also have bilateral talks, really focused on typically your domain you are expert at. So if we decided to define a light standard, we talked to light manufacturer. If we wanted to decide for quantities to work with parking sensor, we talked to CITIC, because CITIC is doing a parking sensor, and so on and so on. The first thing we standardized was the hardware profile ID. Now I will be a little bit faster. We have already 3 standard devices or device classes. We have sensor standard, today supporting 8 defined quantities, like temperature, relative humidity, and so on. We have a standard for binary output. So binary output can drive anything digital, let's put it like this. And we have a basic standard for the light. I'll be a little bit in detail later on. We cooperate with manufacturers, typically from the area that we prepare the standard for. And there is already at least half a dozen of examples, templates, and we also prepared for few of you like Protronics and Netio, the handlers that work according to the standard. There is also a really starting basic database model for the IQRF Alliance repository, the relational model. There is still lots of things to do on that. And of course, last but not least, the gateway part. The gateway part standardized the JSON message format. That is, as you remember in the previous picture, is used in these interfaces and also is going to be used by the drivers very probably. So let me now go a little bit into the detail. Don't worry, it's not gonna be like on Tuesday on the technical committee meeting, but let me touch it a little bit. Hardware profile ID, this is a 2-byte number that, as I said, uniquely identifies a product type. It has 2 parts. You might find it very similar to USB ID. So it has a product ID and manufacturer ID. So manufacturer ID is a unique number that is allocated by Alliance to you, to manufacturer. So we already allocated IDs for Protronics, for Netio, for Datmolux, for MICRORISC, of course, and so on and so on. There are 2 basic manufacturer device classes. We can call them class 1 and class 2. Class 1 is for the manufacturer that will probably have more number of products, and vice versa. We plan to somehow link these manufacturer classes with the membership with the Alliance. It will somehow be connected with the Alliance fee, but also with the benefits, with the certification service, with the support, and so on and so on. As I said, there are already hardware profile IDs for existing products. Now, a few words about the sensors. The standard sensor we defined can handle, as I said, small things, but also it can be scalable for more difficult ones. It can handle a sensor with one and only. By the way, in English, I know only a word sensor. In Czech, we have English sensor and Czech čidlo, okay? And I still have a little bit trouble in my brain how to say that. So let's say it can handle a product having many sensors inside of the same type, of a different type. So it could be monosensor, polysensor, or multisensor. It can have up to 32 sensors inside. Remember that number? It's one of the common patterns I was talking about. We will repeat that with every other standard. It needs only two DPAs, one peripheral, 2 commands, and 3 FRCs to support all the possible sensors, because the development of the sensor standard is now done only by defining a new quantities. Yeah? Quantity is the temperature, quantity is the relative humidity, quantity is the light intensity, quantity is the length, the voltage, and so on. So today we have about 8 quantities already designed or defined with cooperation with you. And on Tuesday, during the meeting, I think our list now, let's say to-do list, is a little bit longer. I guess we have something like a dozen of extra new ones to define. Further development, as I said, is only in means of defining new quantities. So the framework for the sensor is prepared, and we need just the quantities. Every quantity is defined by the unit, of course, the range, the resolution, and there are FRC values also defined. So you can get a detailed values of all 3 quantities, for instance, measured by these protronics by one command, or you can use FRC to get temperature from any temperature sensor of any manufacturer from the whole network. The next standard we defined is a binary output. It's actually the first actuator we defined. It can drive anything digitally on-off, let's say. Okay, whether it's a relay or a motor or the gate or maybe even the on-off light. Up to 32 outputs could be inside one device. So you see, this is the common pattern we are repeating every time. So 32, the same addressing, you know, something that you will get used to it and you will know that you can use it with every other standard again. There is one DPA peripheral to drive it, very simple. Just 2 commands, set and get. By one command you can play with multiple outputs at once, of course. There's a feature we decided based on the experience of you, and the feature is called on timeout feature. Imagine you have a pump, water pump connected to the digital output, and you want to make sure that even if the coordinator blows up, the pump will be on for 2 minutes in order your garden lake will not be empty of water, right? So there is an on feature, so you can say autonomously, please switch on this digital output for a certain time and make sure it's off afterwards. Light standard, the third one. We work with Datmolux mainly on that. It's able to drive a common light with the basic functionality. As I said, we want to have a standards exception-free. You might say, yeah, you are covering just the basic light. Yeah, that's what we want. Yeah, there could be special features. I guess this light has definitely a special feature to make me blind, but there could be even other features, but we are not going to put it in the standard. Again, common pattern, up to 32 lights, 1 DPA command plus 2 FRCs, only 3 commands like set the power of the light, increase or decrease, which is, as we were told, very useful at the real installations. Again, we put an on-time feature, like in the digital output, so the light could be set to the certain power level and then automatically switched off. And that standard supports both unlimitedly dimmable lights or limited, yeah, everything. There are 2 FRCs, because this is very useful in the lighting solutions. First FRC simply says if the light is on or off, because sometimes the light could be, for instance, with the blocked relay, it's on, but you don't want to have it on, but you would like to find out very easily over the whole network which light is on, which is off. And there is also FRC to indicate the alarm state of the light. There are already, as you can see, 4 real products working with the standard. We have custom API handlers supporting them. Plus, we have many examples from the typically IoT starter kit. IQRF repository. As I said, this is something that will run on the network, and it will provide information concerning the products to the gateways and to the cloud. We already created a basic relational model of the database. In the heart of it is the product table connected to the unique, as I said, manufacturer ID plus your company. On the right side, it's more, let's say, execution description. It's linked end-to-end to the standard, the standards I was talking about, plus potentially non-standard things. And maybe the most interesting idea we came up on in January with is the idea of drivers. So again, let me repeat it. Our idea is we don't want to only describe the standard on the paper in the PDF and let you to use it, let you to implement it. We want to have in the repository snippets of code or whatever it's gonna be, the code that could be run in different execution environments. Nevertheless, it's on gateway or on the cloud. So these snippets of the code would be prepared typically by us for standard or by manufacturers of the devices for non-standard things. And this code could be easily used. So no DPA encoding, decoding, bytes and bits and electrons, but ready to use snippets of the code. There's lots of things to do, to design, and we will need, especially in this area, your help. Because definitely me personally, and I can also talk about my colleagues, this is not our expertise. So we will need not only ideas, but mainly also your workforce. Inside of it, I'm back to JSON standard designed by Gateway guys. The JSON standard message would be also used by the driver snippets, because this is going to be a format for exchanging data between the drivers and the network. What are the next steps and the goals we would like to do? We have to follow with definition of the existing standards. We will come up with new standards. We discuss it on Tuesday, what's on the, let's say, shortlist. In the area of sensors, we have a dozen of new quantities to define. And of course, new standards, what I said. One of the hardest topics would be, as I said, the repository. Yeah, quite complex thing. Database, services, we have to think up and come up with the technologies that will do it. Not easy. Drivers, part of it. Last but not least, the topic that we a little bit, make out of the focus, but it's really important, is the bonding. Bonding concepts. Vladia already touched it a little bit by the idea of being automatic. Yeah, that's the right way. Sometimes it's the best way. Sometimes the current button is also an option. And the daemon and the gateway, there's lots of things to do. Dorostia and the team will work on it. I have two acknowledgements at the end of my presentation. The first acknowledgement is to everybody who is really working with us on the standardization. So thank you very much, not only for the work what you have done, but I'm looking forward for the future. And my second acknowledgement is to you for your attention. Thank you very much.